Okay, for example F, we are going to have to rewrite that function so that it is in the proper format for graphing using transformations. And I'm going to go ahead and factor out the negative away from the x or off the x, and factor out that negative out of that whole expression underneath the radical. And when I do that, I get x minus 3. Okay, so if you distribute it back through the expression, you can see that you get negative x plus 3. You get back what you started with, which is what we want. And then I'm going to bring that plus 5 on the end. The function that we have as a parent is going to be the square root of x. And then the table for the square root of x looks like this. It goes 0, 1, and 4 for the x's, and the y's are 0, 1, and 2. And you don't write down the table for every single problem that you do. The only reason I'm drawing this table off to the side is so that as I discuss our transformations, you have a visual of what's happening and something to refer to. But if you were to go and make a table and do all of this work, you might as well just do a regular XY table to start with and not use transformations at all, because this takes time. We're trying to avoid taking time. Let's talk about these easy transformations. The plus 5 means you're going to go up 5, and the minus 3 means you're going to go to the right 3. And now all we have to handle is the two negatives that I have and that 3 out front. Let's start with this guy right here. That is going to be a reflection over the y-axis, and it's going to flip your x values. So negative x means that all of my x values are going to be opposite of what you see, and so all of those are going to flip from being positive x's over the y-axis to be negative on the other side over here. And then this 3 here out front means that we are going to be multiplying our y values by 3. It is a stretch of the y values, or a vertical stretch, and every y value here is going to be vertically stretched by 3. So 0 times 3 is 0, 1 times 3 is 3, and 2 times 3 is 6. All of my y values are vertically stretched and tripled. And then this XY table is no longer going to be used anymore if I were to graph that way. And then also the last thing, I didn't talk about this negative sign here, that is going to actually be a reflection over the x-axis, and it's going to flip all my y values. So all of these y values here, well, you can't really have a negative 0. I don't know why I drew that in, but all these y values are going to be flipped. So instead of going up 3, you go down 3. Instead of going up 6, you go down 6, and it reflects over the x-axis. And if I just clean up all of those ordered pairs that I have left, I would have 0, 0, negative 1, negative 3, and negative 4, negative 6. That's what I'm using on my new origin after I do my right and up shift of 3, 5. Then I would be using those ordered pairs on my pretend XY axis. Now, all of that took a long time, and so you're not supposed to really be writing all that down. This is the mental math that you will be doing as you graph each point one by one. So you first start with your parent function 0, 0, and you mentally do all these transformations and then graph it. Then you take the you take the 1, 1, and you mentally think about all the transformations and you graph that. Then you think about the parent functions 4, 2, and you mentally transform it and then draw the point where it should be. All of this writing down is kind of like a waste of time, and if you're going to do this much work, then you might as well just, like I said, graph using a regular XY table to start with. All right, so let's go ahead and graph. I am going to be moving my origin to the right 3, 1, 2, 3, and then up 5. 1, 2, 3, 4, 5. That's my new XY axis. You are going to ignore all of the numbers that you see on the original XY axis, do not pay any mind to them anymore. If you try to use them, you're going to probably be graphing wrong. Okay, now let's go ahead and graph our function using transformations and not sneaking a peek back here at our little XY table. So 0, 0 is not going to change. And I'm just going to put that on our new origin. And then normally I would go over 1, up 1, and I put my little dot right there. However, we are going to have to triple our y value because of this 3 out front. So over 1, up 3. Not done thinking about it yet because I still have 2 reflections. I need to reflect y, and then I need to reflect x. So I am going to take my y value up here and I'm going to reflect it. And instead of going up 3, I'm going to go down 1, 2, 3. The y value is going to reflect over the x-axis. But I'm still not done yet because instead of going to the right one, I now need to go to the left one because I have a reflection of my x value over the y-axis. I don't even know if that makes sense, but instead of going to the right, now I'm going to go left, and I have finally everything that needs to be done to that ordered pair. I tripled my y, I reflected my y, and then I reflected the x. And then I'm going to check my point. 0, 0 was easy, and let's go and check and see if I'm in the right spot. You were going left 1, down 3, from my new origin, check. And I did not sneak a peek. You are just going to have to trust me. I didn't even look at that table. I was thinking the process through as I graphed that point. I thought about every transformation on that point all by itself and then graphed it. All right, I have one more point that I have to graph. So the last point that you graph with the square root function is over 4 up 2. So I go over 2, 3, 4 up 2. But instead of being over 4 up 2, I need to be triple that amount. So over 4 up 1, 2, 3, 4, 5, 6, which I'm all the way up here. And that's a little scary because I'm off my graph, but no worries because I still haven't reflected yet. I have to reflect my y value over the x-axis and my x value over the y-axis. So instead of going over 4, now up 6, I'm going to go over 4 and down 6. So over 4, down 6, 1, 2, 3, 4, 5, 6. And I have one more reflection to do because I'm not only reflecting over the x-axis and flipping my y down here, but I also need to reflect over the y-axis and move my x in the other direction. So instead of going to the right 4, I need to go to the left 4. So let me backtrack. 1, 2, 3, 4. And then go back to the left 4 spaces. 1, 2, 3, 4, and put a dot. And let's double check that point. Now I'm looking at the graph and I'm left 4, down 6 from my new origin. Let's check it out. Back 4, 1, 2, 3, 4, down 6, 1, 2, 3, 4, 5, 6. Bingo. We nailed it, and all of the points are graphed correctly. And then I'm going to draw in my smooth curve, as smooth as I can get it. And that's where our graph should be. And again, everything that was graphed, all 3 points that I used to graph, you are not supposed to be looking at any tables whatsoever. You are supposed to be thinking of the original table in your head of the parent function 0, 0, 1, 1, 4, 2, and then mentally making those transformations.